Hi everyone, welcome to this video. In today's video we are trying to prove why the derivative of sine x is equal to cos x. So stay tuned. Right, so before we try to prove, we are going to need a few givens without proofs. So this is given without proof. Right, so the first given without proof is that we need that the limit as theta approaches 0 of sine theta divided by theta be equal to 1, right? So that's our first given without proof. And our second given without proof is that we need the limit as theta approaches 0 of cos theta minus 1 divided by theta to be equal to 0. And lastly, we need that if f of x is equal to sine x, that is given in the question, or rather in the statement, that is given in the statement, if f of x is equal to sine x, then it implies that fx plus h will be equal to sine x plus h. So these givens should help us to prove what we are supposed to prove, so which is the derivative of sine x being equal to cos x. So in the following videos, I will try to prove these intuitively, right? The first and the second one, because there are some proofs to it and why they are necessary. But in this video, we're not really focusing on this. So we just continue with our proof. So let's just continue with our proof. So we're just going to say proof here. Right, so the first thing that we have is that f of x is equal to sine x, and therefore fx plus h will be equal to sine x plus h. This is given. This was given, right? So if that is given, we can now continue with our proof and say, therefore f prime x, which is the derivative of a function from first principles, we are going to say limit as h approaches 0 of fx plus h minus f of x all divided by h. So this is how we find the derivative of a function from first principles. So what we know now is, we know that, so we're going to have the limit as h approaches 0 of sine x plus h minus sine x. This will be divided by h, right? Right, so this is what we have now. So we have the limit as h approaches 0 of sine x plus h minus sine x all divided by h. So because we have the things that we were given, for example, I'll just rewrite them here. Actually, I don't have to rewrite them. So as we were given that our first given and our second given, we need to find a way to use these two, because we've already used the third one. So the first one, lim as theta approaches 0, sine theta divided by theta being equal to 1, and the second one of the cos theta minus 1 divided by theta being equal to 0. We need to try and use them. So this means we'll try to manipulate whatever we have algebraically or trigonometrically in a way that will make us to use our givens. So I just want to try to break the sine x plus h using the trigonometric compound rules. So what we're going to have is, we're going to say a limit as h approaches 0, and then using trig compound rules or compound identities, I'm not really sure of the name, this is going to be sine x cos of h plus sine h cos of x, and then we say minus sine x that was already there. So apologies for the inconsistency in the parentheses. So and then we have divided by h. Right, so now if you remember, look at this. We have sine theta divided by theta is equal to 1, cos theta minus 1 divided by theta equal to 0. So I want us to try and do some algebra, that is, try to group the things that have things in common, rather the terms that have factors that are common, right? So as you can see, we have sine x here. Here we don't have sine x, we have cos x, but we also have a sine x here. So we can try to do some stuff using these two because they have something in common. They have sine x in common, and anything else is not in common because cos of h is not in common with anything. Sine of h is not, and cos of x is not. But sine x and sine x, that can make us to do some stuff. So we're going to try and say the limit as h approaches 0, and we're going to group these two, and as we group them, we're going to try to factor out the sine x. So when we factor out the sine x, this side will be left with, because sine x will go, we'll be left with cos of h and minus 1 because the sine x here will go as well, right? So it will be minus 1, and then the term in the middle will remain like that because nothing will happen to it. So let's just say cos of x here, and then all divided by h. So as you can see, we are coming out with something that is similar to what is given here, cos of theta minus 1 divided by theta, because look at this, we have cos of h minus 1. We just need to find a way to put h in the denominator, and then we can use whatever we already have. So now we're going to break this expression in half so that we can do that, so that we can take h to the other part and also to the other part, right? So we're going to say limit h approaches 0 of sine x, and then I'm going to rewrite this like this. So cos of h minus 1, and then I want only the h to be under cos of h minus 1 because we can do that because this is the same as divided by 1. And then here, according to the laws of limits, we are allowed to distribute this limit whenever an expression is broken into into multiple parts. So if this limit was for all this expression, then when we break it apart, we are allowed to distribute the limit. In other words, we can say lim as h again this side of sine of h, and then cos of x, but I want us to leave the h only below sine of h, so as the denominator of sine of h, because we are also allowed to do this because this is the same as divided by 1. So now, as you can see, we have what we want. Look at this. So this is what we want, and this is what we want from our first and second givens. So let's look at our first and second givens. We have sine of theta, in this case h divided by h, and cos of h minus 1 divided by h. Look at this, right? So we have something similar. Now we just need to find a way to bring the limit here, and here the limit is fine, right? So now if you look at sine of x and the limit is h approaches 0, you can see that sine of x is not influenced by this limit because sine of x doesn't have an h at all. So we are allowed to write it like this, right? Because h does not, the limit doesn't influence sine of x at all. So this means that the limit only influences something that has an h in it, and in this case we can group it like this so that it makes sense. And same this side, the h or the limit itself does not influence cos of x because cos of x doesn't have an h at all. So this means we can also group this one like we did and say limit as h approaches 0 of sine h divided by h, and then this is cos of x, right? So now, using our givens, the limit as h approaches 0 of cos of h minus 1 divided by h is the same as 0 because we just replaced the theta as h. So this we can replace with the 0, right? So if this is 0, 0 multiplied by anything here will result in a 0. And then this is sine h. This is the limit as h approaches 0 of sine h divided by h, which is the first given, which is the limit of theta approaches 0 sine theta divided by theta, and then can be replaced with 1. So this is 1, right? And then anything multiplied by 1 is itself. So this means that we will have a 0 here plus cos of x, which is just equal to cos of x. So therefore we can conclude that the derivative of sin x is equal to cos of x. If you find this helpful in any way, just make sure to hit the like and subscribe button, and you can share this with your friends, anyone who also likes doing maths for fun. Yeah, I don't know how to end these kinds of videos, so just do all those things. And yeah, I'll see you in the next video.